Hello, and thank you for joining us today on today's broadcast. Today, we're going to be talking data analytics. And what better question to ask when it comes down to the NFL would be, what's more influential to a team's winning percentage? Is it offense or defense? One might argue that in order to win games, you got to score more points than the other team. And one can also argue that defense wins championships. So, we're brought here to answer that difficult question, but more or less, how are we going to be able to do that? So we have a bunch of our leading experts here today, as I'm joined by a couple, and we'll tune a couple in later. How do we exactly answer this question? Well, in order to do that, we first had to determine what were some of the most important variables when it comes down to offense and defense. Such things like total passing yards, total rushing yards, as well as on the defensive side, total yards allowed passing and total yards allowed rushing. But in order to determine how these variables connected with the team's winning percentage, we first had to retrieve them. So we considered sources like Pro Football Reference and ESPN to try to find these different variables in their numbers. And from there, we had to clean up the data in order to be able to register it and run a bunch of different tests that we'll dig into later with multi-collinearity and running regressions for these data. And then from there, we just had to come up with an interpretation and provide a conclusion and see if we could find an answer to what is the more important to the success of an NFL team. Is it offense or defense? Now, I'm going to send it over to Christian. Christian, can you tell us about what motivated us to find these analytical results?
Well, sure. The motivation basically behind this was that we're all, as a group, football fans, and we all we're interested to find out what variables led to our favorite NFL teams winning football games, and how can we take the data that we found and turn it into a prediction of what our team's win-loss record will be for the 2018 football season.
So, Christian, could you tell me what kind of questions did you have to ask in order to find the results of this type of problem?
Well, we had three main questions when we were trying to figure out this problem. The first is, what was the correlation between points for and win percentage? The second one was, what is the correlation between points allowed and winning percentage? And the third one overall is, what variable had the highest impact on a team's winning percentage?
All right, Christian, so what kind of assumptions did we have going into this project?
Well, we had two main assumptions going into this project. The first one being that points for and points against were large determinants of a team's offensive and defensive ability, despite the fact that you can score points on special teams, whether it's kick returns, punt returns, etc. The second assumption that we made is that positive point differential for a team over the course of a season is a good indicator of a team's winning percentage.
All right, so now I'm going to turn it over to one of our leading data analyst experts here at ESPN, Nathan, who's going to give us a little bit more detail about what went into getting and configuring the data itself.
Thank you, Tyler. So we got our data from our friends over at Pro Football Reference and our own analytics department here at ESPN. We had 16 independent variables that we ran against to determine winning percentage. And in doing so, we got 320 rows of data going back 10 years. And some of the variables that we took into account were margin of victory, points for, points against, total net passing yards, total net rushing yards, and a plethora of others.
Right, yeah, so that'd be even things like on the defensive side, total passing yards allowed, total rushing yards allowed. I think you touched on some of those other things as well, including strength of schedule is another important one there. And there's so many other ones that we got. All right, Nathan, so I got to say I'm fascinated by all this. I mean, you're talking data from two different sources, 16 independent variables, and 320 rows of data. I mean, how are you able to condense all this into one Excel sheet in order to enable further testing?
I'm glad you asked. So what we had to do, well, basically the sort function was my best friend. And so I sorted initially in chronological order based on year. So it got it from 2017 down. And then the second part of that sort function was getting it into team name based on alphabetical order. Once I was able to do that, I was able to convert the sheets over onto one sheet and delete any duplicate rows.
All right, and thank you for joining us back from the break. I'm joined here by two fellow experts, and I'm going to start with you, Nick. What type of models were needed for this type of research?
We started off with the correlation matrix model, and that's where we found out what variables are really correlated with each other so we could remove them. After that, we ran a few multiple regression models where we looked at the p-values, and if the p-value was greater than 0.05, we were able to remove that variable.
Okay, so Nick, it appears that you use the correlation matrix model and the multiple regression model to formulate these results. Were there any types of tests that you could have done that you did not, and what were your reasons for not doing so?
Yeah, so a few different models we could have used was a simple linear regression model or a hypothesis model. We decided not to go with those just because we had so many independent variables that we were looking at. For the simple linear regression, you can only have one to use. Along with the hypothesis, we just had too many variables in our data set that just wouldn't work out for those two models.
All right, so now I'm going to turn it over to Jackson here. Jackson, my question is, with this correlation matrix test, what were we looking to find here?
So with the correlation matrix, what we were looking to find is multicollinearity, which means when two independent variables are too correlated, and therefore they'll mess up our data. So what we did is we ran this correlation matrix and tested for variables that had a correlation value of over 0.7. These variables included point differential and margin of victory, and so we were able to eliminate those independent variables and then further run regressions.
So now that we have the correlation matrix testing done, what was the next step in the testing process?
So after the correlation matrix, we ran regressions, and what we did with those regressions is we looked at the p-value for our independent variables. We were able to eliminate variables one at a time based on variables whose p-values were above 0.05. And the reason we looked at variables with p-value of above 0.05 is because those variables were determined to be not statistically significant to our dependent variable, which was winning percentage.
So ultimately what you're saying is that any of these variables that had a p-value below 0.05 were statistically significant enough to the winning percentage.
That is correct, and we were able to boil it down to two variables, and that was points for and points against, that both had p-values of below 0.05.
We're just going to analyze each of our favorite teams based upon this point in the season and look at what we think our team's going to finish at for the remainder of the season compared to what the regression model thinks that our team is going to finish at for the rest of the season. So beginning with Nick. Nick, you're a huge Bears fan. They're sitting at 8-3. What's your prediction for them for the rest of the season?
You see, Tyler, I'm predicting the Bears are going to finish the season at 13-3 this year.
Woo!
With Khalil Mack on the defense and Trubisky as a quarterback, they're just unstoppable so far. I did do a little research on my own, though, and I found by plugging in their current stats in our regression model, they're probably going to end up about 12-4 at the end of the year, which still not half bad and still make it to the Super Bowl.
All right, now we're going to switch gears to Christian's favorite team. We got the Indianapolis Colts here, currently sitting at 6-5 on the year. Christian, what's your prediction for the remainder of their season?
I predict a strong finish this season for the Colts. They've won 4 in a row, and Andrew Luck's having a phenomenal year, and their offensive line is coming together at the perfect time. I predict them finishing 10-6 and sliding into the second wild card spot in the AFC. According to our regression model, it also has the Colts finishing 10-6, which will hopefully give them a playoff spot and hopefully a playoff run.
And now for Nathan's favorite team, the team that seems to have success year in and year out, the New England Patriots. They're sitting now at 8-3, another successful season thus far, but what do you think is going to be the case for the remainder of their season?
Well, I think that they're going to go 12-4. Clearly, the regression model does not agree with me, and they do not take into account Tom Brady and Bill Belichick's connection. They can run an offense. They can run a defense. They're going to go all the way this year. There's no doubt about it.
And now for Jackson's favorite team. Jackson, we got the Pittsburgh Steelers, who are currently sitting at 7-3-1 with that devastating tie to the Browns in Week 1. What's your predictions for the remainder of the season?
I think the Steelers are going to finish strong. They've got a good offense. Their defense is finally coming together. I think they're going to get one more loss and win out the remainder of the games. The regression model doesn't quite agree with me. It has them sitting at 10-5-1 at the end of the year, but we'll see what happens. How about your favorite team, Tyler? The Atlanta Falcons. I know the Steelers handed them a loss earlier this season. How do you think they're going to end?
Well, I mean, it's been a tough season so far. We're sitting at 4-7. Unfortunately, our offense is doing quite well. It's just on the defensive side of the ball. We had a lot of injuries early in the season, which were devastating injuries with some of our Pro Bowl safeties and cornerbacks. So it's been a tough season so far. I got the Falcons at 7-9 for the remainder of the season, and that also agrees with our regression model's predictions as well. So some of you viewers may be wondering how we were able to configure our favorite team's winning percentages with that regression model. And Jackson's going to tell you guys exactly how we were able to do so.
Yeah, so as you can see, our model is a standard regression with two different variables. So we start off with 0.573, and then we add a multiplier for points for, and then a negative multiplier for points against. Now, these multipliers are small, but you have to remember that we're dealing with a decimal already for winning percentage, and then we're also multiplying by large numbers in the points for and points against column. For the 2018 data, what we did was we averaged the number of points per game and then multiplied that by 16 to take it over the course of an entire season.
In conclusion, we were unable to provide a sufficient answer to the question of which is more influential to a team's winning percentage, offense or defense. Although offense had a slight advantage over defense, it was not enough evidence to give a case for either side. So in this case, it's going to be up to both, ultimately, to provide enough conclusion for a team's winning percentage.
Yeah, and from the variables perspective, we were able to determine that the most important independent variables were points for and points against, which influenced our dependent variable winning percentage.
And these conclusions make sense because the two variables, points for and points against, are the two main variables to go into if an NFL team wins a game or not.
Right. And although our independent variables did not influence winning percentage directly, we believe these variables would have come out differently if we were to use, let's just say, points for and points against as a dependent variable instead of winning percentage. Also, it's important to consider that each NFL team has different strengths that they rely on each season. I mean, you consider the Super Bowl champions for both 2008 and 2009. In 2009, you have the New Orleans Saints, who won the Super Bowl and had 510 points for and 341 points against. Now, you compare that to the Pittsburgh Steelers in 2008, who had 347 points for and 223 points against. In this case, you can obviously tell that the New Orleans Saints relied more on their offense than the Pittsburgh Steelers did, and the Pittsburgh Steelers, in comparison, relied more on their defense than the New Orleans Saints did in that regard. So ultimately, what is more important to an NFL team's success? Is it offense or defense? We can't give the case for either, so we have to say the answer to this question is both. Ultimately, on the offensive side of the ball, their objective is to increase the amount of points scored. And on the defensive side of the ball, their objective is to reduce the amount of points that they allow. So, based upon our research, if a team is able to do both of those at the same time, they will be likely to increase their winning percentage. And that's all we have for you today, folks. Thanks for tuning in. I hope you enjoyed the show.